What if the most powerful telescope ever built just detected light older than the Big Bang itself? For decades, we believed the horizon of our knowledge was fixed at 13.8 billion years. But today, that wall is crumbling. What if the universe never actually started? What if the Big Bang was just a curtain, hiding a much older, much deeper reality? What if what we see today is just the vestige of a forgotten cosmos? Stay with us until the end, because what you are about to discover could completely redefine your understanding of time. We are looking at data that current physics cannot yet explain. The secrets of the deep past are finally speaking. If these revelations intrigue you, stay with us. What we are about to discover goes beyond anything you can imagine. The history of everything is being rewritten in real time, photon by photon. Since the beginning, we've been told the universe was born 13.8 billion years ago. A single point of infinite heat and light that expanded into everything we know. But three massive questions are emerging today. Why is James Webb seeing galaxies that are way too evolved for such a young universe? These are not the small, chaotic clusters we expected. They are mature, majestic, and perfectly formed spirals. How do we explain massive structures appearing only a few 100 million years after the start? It's like looking at a newborn baby that already has the wrinkles and the deep, heavy wisdom of an old man. Is it possible that some light comes from a universe prior to ours? In this video, we will explore the anomalies of James Webb and the most troubling theories: cyclic universes, hidden dimensions, and ghost matter. The standard cosmological model is clear. Big Bang, then the first stars after 200 million years, then galaxies much later. But James Webb is observing something else entirely, deep in the infrared void. At distances corresponding to only 300 million years after the Big Bang, it detects galaxies with multiple stellar populations and heavy elements like carbon, oxygen, and even iron. This shouldn't be possible. Heavy elements can only exist after several generations of stars have lived, died, and exploded in supernovae. This takes time, a lot of time, much more time than our current timeline allows. And then there are the monsters. Supermassive black holes, billions of times the mass of our sun, sitting right at the dawn of time. According to our models, they simply wouldn't have had the time to grow so large. Astrophysicists now face three possibilities. Either our distance estimates are wrong, or structure formation is much faster than expected, or our understanding of the beginning is incomplete. The most prudent conclusion is not that the Big Bang is false, but that our version of it is too simplified. What if the problem wasn't the galaxies, but our definition of the commencement? What if the Big Bang wasn't the start, but simply a phase transition? A moment where something shifted state. Since school, we've been taught it was an absolute birth, but reality might be different. The Big Bang theory describes expansion, not creation. It tells us how the universe went from a dense, hot state to the vastness we see today. It says nothing about what happened before. In general relativity, if you go back in time, the universe becomes hotter and smaller until it reaches a singularity, a point of infinite density. But in physics, infinite means the math has failed. Leading modern theories propose an elegant alternative, the Big Bounce. In this model, an ancient universe contracts slowly over billions of years. Density increases, but it never reaches zero. Instead of collapsing into a singularity, a quantum mechanism intervenes. The universe bounces and starts expanding again. Our Big Bang was the moment of the bounce, a transition, not a birth. This model solves several paradoxes. It eliminates the infinite singularity. It avoids the question, what was there before? It allows for a universe that is potentially eternal and cyclic. Some anomalies in the cosmic microwave background, This fossil light from 380,000 years after the Big Bang could be the physical imprints of a previous cycle, gravitational scars left on spacetime. As if the universe kept a subtle memory of its past, every cycle, every transition, every phase leaves a signature. We might be looking at the fossils of a world that existed before time. If the Big Bang is a transition, then time doesn't start at zero. It flows through cycles. What we call our origin is simply a local horizon, a point of passage, a change of cosmic phase. This changes everything. If there is no absolute beginning, the question, why does it exist, takes on a new dimension. Everything we see is the continuity of a much older story. James Webb isn't destroying science. It's revealing its limits. It shows us that reality is not a straight line, but a complex network. Maybe time itself is emergent, appearing only when matter is organized. We thought we were observing the first moments of existence, but perhaps we are observing the echoes of a much older process. The Big Bang is not a birth, it is a spectacular transformation. Since the dawn of time, science has progressed through doubt, not certainty. Today, James Webb is moving our very idea of the beginning. We are not at the start of the story, but in the middle. Every photon captured by James Webb is a messenger. It has survived collisions, stellar explosions, and billions of years of expansion to tell us one thing: the universe remembers. Next time you look at the night sky, remember, you aren't just seeing stars, you are seeing memories. You are looking at traces of a past older than our own notion of time. You are part of the cycle. Somewhere right now, a photon is reaching your eye. It carries the history of a forgotten world, an ancient universe, and it has traveled for an eternity just to find your gaze. The story continues with you. If you enjoyed the video content, don't forget to like and subscribe, and let the information come to you. Welcome to Science Nucleus, where we explore the core of reality.